Our next speaker is Trevor Gamblin from BayLibre.
Hi, thank you for coming. Where's the... I'm here to talk to you today. My name is Trevor, to talk to you today about the challenges involved in building Python packaging infrastructure for the RISC-V64 ecosystem. So an agenda for this talk, I'm going to give a quick intro so you know who we all are. I'll get into the experience of using Python and RISC-V64. I'll introduce the Wheel Builder project, talk about some of the challenges we're experiencing, and then conclude the talk. So a quick intro, you probably already know who RISE is at this point, but I'll just say that they are driving the software ecosystem for RISC-V forward. I'm from BayLibre. I've been with them for just over 2 years now. We're a services company specializing in all things embedded, so Linux kernel development, Yocto, U-Boot, Zephyr, compilers and tool chains. And you'll actually hear from a colleague of mine in a little bit about that. One of us on the team, Mark, is from Rivos. They're an active member of the RISC-V community bringing high-performance AI solutions to the data center, and they actually have a booth outside if you want to know more about that, so feel free to visit them. So I'm going to get into the experience of using Python on RISC-V64, but before I do that, let's do a show of hands. How many people in the room find themselves doing some sort of Python scripting for data science or automation at least once a week? Okay. How many of you tried doing that on RISC-V64? Okay, good. So for reference, the device setup I'm using in the examples I'm about to show, it's a Vision 5.2 in my board farm at home. It's running a fresh install of Ubuntu 24.04. I haven't done much to it. It's a fresh install with the exception of a system update, and I've installed a few build tools that I'll explain why I did that in a few slides. The system Python is 3.12.3, and I've set up a virtual environment for the examples coming up. So in this slide, you can see me doing something everybody loves to do, which is time the install of the packages they want to use. In this case, I'm installing NumPy on the system. And you can see it takes a whopping 17.5 seconds to do this that way. And if you look closely at the log, the standard out, you can actually see it's building NumPy, which seems a little bit unusual if you've tried to do this, or you probably have done this on any other system. Yeah, it's taking quite a long time. And for comparison, I did this in an emulated environment on my Ryzen 9 system, which I have at home, and it still took 8 minutes, which is pretty drastic. Another example I'll show really quickly is doing the same thing for matplotlib. So you can see in this case, pip is going out and getting a bunch of source distributions and building them as well. And I had to cut this short because it was quite a long log in comparison, but after 11 minutes and 37 seconds, it reports an error saying it couldn't find a dependency for pillow, which is needed. We could work around this. You know, there's a lot of capable people here who could certainly figure out all the dependencies and make this work. But should we do this? You know, if you're trying to do the same thing on x86-64, you're just going to run pip install matplotlib, and it's going to work, and it's going to take maybe 10 seconds. So to understand why this is happening, we have to look at how pip works. So it's a Python package installer. It searches an index for package, in this case, by default, pyp.org, matching your host architecture, which is an important point, or if available, it'll pull a Python wheel, or a pure Python wheel. If it can't find a match, it'll go and download a source distribution and try to compile it itself, which is what you saw a couple slides back with NumPy. The kicker is that there are no RISC-V64 binary wheels available on PyP right now, so pip is going to do this for every package without a pure Python wheel that you try to install on a RISC-V64 platform right now, and there's a link to a discussion explaining why that's not possible yet. More importantly, even in the case of NumPy, which is why I had some of those build tools installed, it actually fails as well, but I wanted to make sure it did finish just to see how long it would take as an example. There's no guarantee that this is going to be optimized the same way that you expect an upstream distribution might be. NumPy, again, as an example, has dependencies on libraries such as OpenBLAS, and they actually pin specific releases to very specific versions. And if you've installed something different, there's no guarantee that you're going to get exactly the same behavior that you're expecting. There's a bit of a dilemma here. As mentioned before, it takes quite a long time to do all this building. And NumPy itself is bottom of stack. So it doesn't have many dependencies, but looking at the matplotlib example, it had to pull in a lot more Python libraries that weren't successful at installing and building. There's an alternative here where you could stick to the pure Python standard library and pure Python wheels, but there's going to be very limited workloads that you can actually achieve with that. Or you could try to work through the process of getting all these packages to build manually for your environment, but that's a lot of extra setup and debug. And really, this is a major deviation from what, you'd expect on a different platform. And I have a link here to my colleague Mark's talk at FOSDEM earlier this year where he goes into more detail with some examples about this. So the question is, what can we do? What is the solution to this problem? The answer is the Wheel Builder project. So Wheel Builder is a repository hosted on the RISE project's GitLab with two main goals. The first one is to lay the groundwork for default RISC-V64 support in Python. And the second is to enable AI and deep learning applications. From the user perspective, it's a package registry offering tested wheels for Pythons 3.10 through 3.13 right now. It also includes documentation. Under the hood, what it consists of are GitLab CI pipelines that closely try to mirror upstream projects pipelines for their respective builds, specific patches for different architecture and automation problems, and we use customized many Linux environments on emulated platforms to do all of the building. And we also mirror some upstream repositories. This is just another look at the kind of dependency tree we have to deal with. This is VLLM, and this is just a cut-off snapshot of all the dependencies it has in its tree. And looking at this list, I can tell quickly, there are several of these on here that have compiled binaries available that we have to work through building as part of the Wheel Builder project. Charset normalizer, Pydantic core, multi-dict and prop cache, several others. So when you're talking about trying to use something like this on RISC-V64, there's quite a lot that you have to have build successfully in order to get started with your application. This is a quick look at the Wheel Builder binary package list support as of March. By now, we're actually supporting 49 different packages in the repository. It's important to note that the list here, which is also on the poster we have outside, is a ranking of the binary packages on PyP, not all of them. So we're not including pure Python modules, which we're not concerned with in this project. But you can see we have many of them already supported in multiple versions, and there are some more that we're planning support for. So how does this improve the user experience? So going back to the NumPy installation example, all you really have to do is upgrade to pip 24.1 or newer, and then set the pip index URL, which is available in the documentation on the project, and run the same command as before. I'm timing it, time pip install NumPy, and you can see in this case it takes 21 seconds. So it's a pretty big improvement. So what are some of the challenges we've experienced so far? The big obstacle is just general case of long build durations for the packages for multiple Python versions. Again, we're supporting 3.10 through 3.13, so that's quite a large build and test matrix. There's a lack of distro support. Ideally, we want to be using an LTS Red Hat-based distro, and we're hoping that will appear in a new Rocky Linux release coming soon. Upstream generally doesn't test for RISC-V64, so the tests don't necessarily pass even when the wheels build, and the RISC-V64 infrastructure isn't there yet. There are issues with canonical not a numbers, where essentially the not a number value doesn't propagate as expected, so tests in packages that would test for that fail where they would pass elsewhere. And an interesting one we've run into quite a lot is we have to take some extra responsibility for IP. Some of the packages we're building, what we found in particular with some that build with Rust is the licenses aren't necessarily getting built into the wheels when something like Maturin goes and builds them. So we have to take that into our own hands and then communicate with upstream to help them fix that. I've distilled this into essentially 3 levels of complexity for support. So there's easy, where we just update the mirror of the repository and add a new tag for a package version and trigger a build. It builds the wheels, tests them, and then uploads them to the registry. There's the medium category, which is that, but we have to add some new dependencies and maybe change some patches around. And then there's hard. An example I have of that is building UV, where we have to do all of the above, plus we have to very carefully look at all the tests we're running to make sure they're all doing things we expect and that there are no surprises with the outputs there. So what's coming next? This is another slide that's been is a little outdated since it was actually written. So we're targeting the top PyP packages plus VLLM and Haystack. We've also added SGLang and PyTorch plus all their dependencies to our targets. We're going to continue maintenance and support as new releases come out for each package. And more importantly, we're going to work with upstream to make RISC-V64 more accessible. We've already started doing this, but long-term the goal really is to be upstream first. This is really just a stopgap to enable people to get started on RISC-V64 until this is supported upstream. And finally, we want to discuss with the community, including you. Special thanks again to the RISE project for funding this work in the first place. My colleagues Mark Ryan and especially Julien Stephan, who couldn't be here today, but who's been doing some really incredible work on the automation system, and the Python and RISC-V communities. Thank you. I'll also add that we have a poster upstairs, so if anyone wants to talk in detail, visit us there.